Ladies and gentlemen, welcome to the archive. On each episode of this podcast, we sit down with either a founder, a creator, a builder, or someone excited about Arweave and the Permaweb in general. And in this first episode of the archive, we have a very special guest, Sam Williams, who is the creator of Arweave and the CEO at Forward Research. With no further ado, let's jump straight into this episode. On today's episode of the archive, we're receiving a very exciting guest who is Sam William, the founder or creator of Arweave and CEO at Forward Research. Sam, happy to have you today.
Thanks for having me on.
Okay, so for people listening or watching this at some point and they don't know much about you, can you just give us a little bit of introduction about yourself and the work that you're doing?
Sure. Yeah. So I started building Arweave 8.5 years ago, and it's turned into the network that we all know today. Over that period, about 3 or 4 years ago, we started Forward Research, which is an organization focused on building not just Arweave but the Permaweb stack. Essentially, striving towards this vision that we see for a trustless and ownerless cyberspace, which is really made possible by permanent information storage at the base layer, but is not actually like just Arweave as an archive, if that makes sense. It's that permanent information, one of the things about it is that it's out of the control of the person that published it in the first place. And so, in cyberspace, information is land, if you will. It is the set of environments that we inhabit. And when you make that owned by no one, you enable this thing we call trustless, decentralized web. And so, we've been really pushing towards that. We serve this function in the ecosystem of more or less picking up everywhere that, there's an area that someone needs to build something that is not necessarily like super commercially viable or is just a very large scale project. And so isn't typically done by a team in the ecosystem, or will be harder for a team to spin up to do. We sort of take those roles. But we really just exist to, help the Permaweb in whatever way it needs in any given day. Sometimes it's building a compute system. That's been our latest endeavor, building AO. But at other times it's been building the licensing infrastructure for data on Arweave with the universal data license and all sorts of other things along the way. And I imagine we'll continue playing that role for quite a few years to come.
Thank you very much. And I think that prompts me to the very first question. So we have Arweave down as the sort of base layer of this Permaweb stack, and everything just builds on top of Arweave. And we are going into the eighth year of Arweave, or of Arweave mainnet. I don't know how to phrase that. So how has the growth been from that time, from the mission at the beginning, which was to preserve to preserve data and to preserve users' rights and all that, up until this point? We can somehow say that the network is there, is working, and it has proven to be working for 8 years. But how has the journey been, if you can reflect a little bit on that?
The journey has been incredible. I mean, it's the most meaningful thing that I could have imagined or hoped might happen in my life. I'm very, very, very grateful for that every day. Arweave, when we started, was just an idea I had that it would be good if we had an archive that could store humanity's knowledge and history for generations to come in a digital way, rather than depending on these sort of error-prone and disaster-riddled analog forms. But when we started, the idea of a permanent information storage system was pretty out there. And now, so that started working on it 8.5 years ago, but the network launched a year after that. The growth over that time has been really incredible. And you're right, it's proven itself, at least to some extent. It's a permanent information storage system, so it's cool. It's like been alive for 7.5 years, but 7.5 is like a tiny fraction of what we're shooting for. But still, like, it has some some credibility now and some resilience just as a result of being battle hardened in reality. So that's amazing to see, but perhaps more so is the set of people that have congregated around it. The fact that so many other people have heard about the mission and yeah, and identify with it enough to put their time into helping it happen. It's really incredible to see. It's been a journey with a lot of interesting twists and turns, I suppose. But yeah, the most meaningful thing I've ever done, and I expect probably ever will do. I'm very very grateful for it.
Yeah, and I think so. So Arif started. Obviously, there was a team behind that built the network, and the network was out there. But now, looking at it today, we have probably billions and billions of data items stored on Arweave. And I think this was mostly derived by in my opinion, the applications built on Arweave. So sort of saying, so Arweave is there, it's working, but not everyone just can use it directly. So like there has to be some apps on top, like R Drive and all the other apps in the ecosystem, trying to make sure like people have access to this permanent data. And I presume one of the first pushes of that adoption was the builders who were part of the open web fellowship or something like that. I think I watched many of those videos that are still up there on the Arif channel, and it's just interesting to see how, in my opinion, for some of these people, it just clicked and they knew what it was and what they wanted to build, which some of those applications still exist and work in the ecosystem perfectly. So how I think you were the one running at least the calls that I watched, and as the founder, as the creator of Arweave, watching people come to build on this thing that you built in there, how was that? How was that? How did that feel, in a sense, if you can probably talk about that, and how, and also all the ideas that you saw people building, are those things you had in mind at some point, or you're also mind blown by what people thought they could build on top of Arweave?
Definitely a mixture. There were some things that it's a strange thing to build in a way because it's such a open primitive, permanent information storage. It's like three words really, and it's simple in some sense, but it has profound implications. And so the design space for things that you can usefully use that for is very, very, very wide. But as you said, you can't just go to the protocol and usefully use it as a consumer by interacting directly with the API. It doesn't work like that. You have to access that primitive technology, that capability through some type of interface. So we had dozens, I was about to say hundreds, probably a bit far, but like 50 ideas that we thought would be great, great new services that you could build on top of the system. And and then people came and they started building those, but they also built a ton of other things, probably 50 I would even say, things that we didn't imagine were possible, or yeah, just kind of outside our, what would you say, outside the zeitgeist or the institutional mind, if you will, of things that or areas we were exploring. So that was really really cool to see. And yes, you're right. There was actually only ever one Open Web fellow, and I think no, they were called Arweave fellows. Sorry. Well, they rather one person. It was Phil, who built R Drive, and that was an interesting experiment. Phil had been around since the testnet days of Arweave, mining the network. And he basically just messaged me one day and said, "Hey, I'd like to quit my job and build something on Permaweb, not sure what." And we were at the time trying to work out, well, what's the best way to foster ecosystem? And so we had a theory. Well, what if we just like pay someone to, not a huge salary or anything, but enough so that they can sustain themselves, for say 6 months and just experiment with things and see what they build. And obviously, kind of, the rest is history, as they say, right? Phil first built Rdrive, and in building Rdrive, realized quite how important the gateways were, and started building Aria. Yeah, that became a whole behemoth of its own, in its own right. And yeah, you're absolutely right. Then after that sort of individual instance with Phil, we thought, okay, well, how can we scale this so it's more like a program, where people can basically get started? People that are interested in the Permaweb, they can learn what it does, all of the open sort of greenfield opportunities we see, and then come up with their own as well. Yeah, and then go from there and turn it into basically fully fledged applications and projects, sometimes protocols built on top that serve end user needs. And that was the Open Web Foundry. And yeah, I was certainly on some of those calls, but I would say it was Seb, who is our COO now at Forward Research, but before that was the COO of the Techstars batch that we went through in as a startup accelerator in Berlin. And so that was where I met him. And yeah, he just helped us sort of roll out an accelerator program. And then we did that for 2 years, probably, maybe a little bit longer, something like that. And then we've just been sort of adapting over time to what we see the ecosystem needs and filling those roles. So first it was sort of wide incubation, and then later over time it was like more strategic investments in particular pieces of infrastructure that we thought would make the whole of the Permaweb more powerful and useful to people. And yeah, sometimes it's at the application layer, other times it's protocols, deep infrastructure, and like I said, even occasionally like a license or something. It's really outside the domain of typical building and engineering you would imagine as a tech founder.
Oh, nice, interesting. Yeah, I think it's just very exciting to see those videos and see the like how people were, I would say, excited on those calls, like exploring this new like exploring Arweave as a new thing that probably they were not so much used to something like that. And I think from what I've seen is most people who joined were a little bit intrigued on like the model that Arweave works on, which is like pay once, stop permanently. Yeah, I was almost saying forever, but I've watched some videos where you say you don't like the word forever. So
Yeah, that's true. Yeah.
and it's excited to me to see that almost I think almost everyone who has built something in the Arif ecosystem has come either from uh, the excitement that there is this storage protocol that you just pay once and you store permanently, or they are skeptical that it actually doesn't work. So like, they have to explore and see where things fail or
Yeah.
where things don't work, and they end up seeing things working exactly
Right.
as they accept them to.
Yeah, which is also, I mean, for the same reason that I don't like the word forever. Although engineered for the storing data for the maximum possible time period is absolutely atrocious marketing. So yeah, somewhere in between here, we got to find the right the right way to describe this over time. But yeah, I mean, if I were on the outside, I would also be super skeptical, and I think we've so curated a good culture over time of people really digging into how the technology works and why it works, what are the failure modes, and this type of thing. It makes it an honest attempt at building something very, very, say non-trivial, to say the least. It's a bold mission, but I'm glad that the people that we've found along the way and have decided to spend their time building with us are all sort of often skeptical, sort of careful thinking type people rather than just going along with something. Anyway, yes.
Yeah, 100%. And so I'm just thinking from the way things started, where it was all about Arweave and building on top of Arweave, to I think last year. Now it's actually not last year. But then after storage, there was this sort of, I don't know if it was a need or it was an exploration where like the there has to be compute on top of storage. I don't know if it was by design or that just came along where like, hey, we have this storage, but like, what if we build compute on top of that? And that started, I think, with SmartWeave and now AO the computer. So was that sort of in the plan or it just happened? Like it's a realization that happened along the way.
It was definitely a realization that happened, but it was actually in 2020, in about March, April time in 2020. We just realized that, yeah, basically the consensus about ordering of inputs to smart contracts is the thing that matters in smart contract systems, not the actual execution. And that created this notion of lazily evaluated smart contracts, which again is also, I'm afraid, bad marketing. Lazy sounds. CoinDesk wrote an article at that time, said Arweave's approach to lazy approach to smart contracts or something. That doesn't sound good. But it's from the functional programming world where basically you can delay execution to a later point in time. In that sense, it's lazy. Yeah, we saw that this was possible using Arweave base layer for what we would now call schedule generation or scheduling in AO. But back then it was just like, ordering the transactions. And then you can evaluate on top of that deterministic and publicly available ordering of inputs. You can evaluate it at any point in time and you can get back the result. You don't need to come to consensus about the outputs of the computation, just the inputs. That was the key observation that started it. And that was, yeah, SmartWeave was early 2020. And it was also one of the things that led to the explosion of people experimenting with different downstream applications on top of Arweave. I don't know that it was necessary, but I have a strong hunch that it was a large contributing factor to people starting all those projects on top of the network. Yeah, and then we started building AO because shortly after SmartWeave came out, we saw this. So let's see, SmartWeave was 2020. Yeah, right. Arweave 2.0 launched at almost exactly the same time, probably a couple of months earlier. And Arweave 2.0 created the system of adding Merkleized data routes to the network rather than like all of the bytes in one serialized form. That was the way that things worked with Arweave 1.x. And that allowed massive scalability. And also part of that from the beginning was this idea that, yeah, we should have bundles. It was actually ANS 102, which almost no one seems to know about now, but it was like a JSON encoding of transactions where you could bundle them together. It wasn't very like space efficient, which is why it got replaced with ANS 104 in the end. But it was the same idea. Take lots of individual interactions from different users and settle them to the network in one go. And then you can have scalability of the number of items that are being written, not just the amount of data in aggregate. And so we could see shortly after that, well, okay, if you could take that system of bundling and apply it to the inputs to these transactions, then you could end up with any number of parallel threads executing at the same time inside this smart contract system on top of Arweave, and then orchestrate them somehow. And we sort of knew the answer to that was message passing. It wasn't entirely clear how that would work, but broad strokes, like they should be able to message each other. And then there you go. You have an actor-oriented, arbitrarily horizontally scalable smart contracting system. And so we knew about, I would say, 80 to 85% of the design from 2 months after SmartWeave came out, which was really early, but we were just busy basically helping teams in the ecosystem build out their projects on top of it for a long time. And also, at the time there was Warp, and later Yeah, there was Permaswap got started around then. Uh, they were sort of expanding on the SmartWeave model, and so we thought all the better. Like let the what did they say? Plant 100 seeds, something like that, and let the trees grow. And so we sort of did that, but neither of those two systems in the end uh, created this actor-oriented model that we had in mind that would lead to truly horizontally scalable smart contracting systems. And so by when was it? Yeah, it must have been mid 23, I suppose. Yeah, that's right. Um, we sort of saw this need, and actually, it wasn't just that we saw the need; we had the need ourselves for a smart contracting system at this scale. It was that we wanted to support trading of content on Bazaar for Odyssey, and there are so many pieces of data on Odyssey and so many users that the only way that that would really work is if you have two things. One, just horizontal scalability. It's going to be millions and millions and millions of interactions. It was pretty clear from the beginning. And also running agents in the system. Like, we don't think that the content economy will work with people individually picking, I want to buy into this video at this amount, this valuation. Very often that will happen occasionally, but much more frequently there will be just agents essentially that say, hey, look, the marketing revenue, ad revenue from this video is X amount. I can predict that the slope of interaction with the video will look like this, and subsequently at Y price. It is it's valuable or not. I should buy or sell it, and so then you can create sort of fundamentals driven valuation of content on the internet, and then while you do so, you unlock the value of videos in the future. Today, for content creators, that's helpful because then they can go buy better camera or whatever it is that they need. It's just an economic efficiency. The same thing you get with farming. Actually, you sell futures on the corn that you're creating, and all sorts of other components. So we needed that infrastructure ourselves, and that was what basically pushed us over the line, you could say. First, we tried to take it to existing parties in the ecosystem. We built out this basic architecture for, hey, here's what a message passing based system could look like, built on top of Warp or Ever. And we saw that like both systems could do this, or ideally even there would just be a mutual standard that allowed talking between them. And you could just have as many threads of those individual parts as you wanted, but neither were particularly keen on building this, and we needed to use it. So one way or another, just ended up stepping in and building it. And then we started with like, okay, well, let's just build it as a sort of data bridging layer on top of Warp. It was originally called HyperBeam for Warp. In fact, AO was called HyperBeam before. It's kind of come full circle on that one. So there was HyperBeam for Warp contracts, and soon enough we realized, okay, actually the execution system, it would probably just be easier to sort of fork it out and make our own. And then it became AO itself, and Warp ended up helping us with some of the early adoption work for AO itself, kind of rolled it into one. The rest is history, I suppose.
Nice. And I think it's good that you've just talked about HyperBeam and AO, because I was going to step in that next. So February 2024, AO launched, I think, in February last year. And we were all excited about AO. And I think I was personally excited on like how simple it was to test it out. Just because I think when like everything comes out, since like for most people you don't know much about it yet, you want to, there is a sort of like, I don't want to call it learning curve, but there is a time to catch up to any technology. But with like, especially with AOS, it was like very straightforward. From the terminal you could try to play around with it, And I remember when the chats were out, like you could just log in and you can see the chats coming in. That
Yeah,
was
sure.
awesome. But I think so. We went from AO testnet, and you can correct me here if something is wrong. But we went from AO testnet to around February this year to mainnet, but then there was a change into like hyper. So there was HyperBeam as the protocol, and then there was AO on top. Uh, I suppose, but then that was, I think, in a sense, it was personally, it was exciting. Like I was excited to see that and see how things work, but then it also ended up confusing me personally and like so many other people. Like, wait,
Yeah.
so we we had AO the computer, now we have HyperBeam, and then we have HyperBeam and AO on top. Like those, just a lot of moving pieces. Was like I, I just want to like sort of understand what happened between AO testnet and the time we got to AO
Yeah.
mainnet.
Yeah, that was an interesting time to say the least. Okay, so the way that the nomenclature we use, at least, is that Hyperbeam implements a system we call AO core. That's like the primitive, most fundamental components of the AO protocol. And then AO processes are actually a sort of what we call them a device that lives on top of AO core. And the reason that we did this is so when we were building Arweave, we got to the right architecture after about 4 years, I think. And that meant that there were unfortunately about a dozen hard forks, no, probably 10 or so hard forks along the way that pushed the protocol in the right direction. But they added this baggage that like it wasn't quite perfect yet. And there's 10 incremental versions that are still not quite perfect. And then we finally got to the right one. And I just saw the effect that that has on the velocity of development over time. Like how much can you actually get done as a team, and the ecosystem on top of it. Like how much time is spent just dealing with the fact that things are changing. It slows things down a lot. And so when we were building out a testnet to mainnet, we were trying to come up with what is the purest, most say abstract or simplest version of what AO could be. What are the like basic primitives involved, and how can we formalize those in such a fashion that we're confident that we won't have to change them often in the future? And the more we looked into that, the more we realized that, well, that in the legacy net system, there were moos, coos, and soos, the messaging units, the compute units, and the scheduling units. It became pretty obvious to us, actually, when we were building out the mainnet compute unit, that really like these pieces of functionality, things like cron actually was the thing that really did it for us. Is okay, cron is a standard that we're all using today. That's great, but what happens when someone builds like a cron that is better in this way or that way? Like there's actually a bunch of different ways that you could argue the cron system alone should work. Or what about the security system? Like when you see it, it's almost like each of these are different pieces of general purpose compute, and the ideal version of AO would allow you to flexibly and in a modular fashion reconstitute whatever type of structure you need in order to achieve the task you have from the same set of basic primitive utilities. And that was where AO Core got started. We noticed that at its most basic level, really what we're talking about is deterministically ordered and available data as inputs to computations. That's kind of it. And that doesn't mean that, well, actually, that's not even quite true. It's more basic than that. This is the system that became hash paths. It's really like collections of inputs, you could even say. There's a form of hash paths that doesn't give regard to ordering. which can be useful for certain things where it doesn't matter if Alice did something before Bob or Bob did something before Alice. It's just that they both did things that is important to the computation, and that has different downstream yeah, computability characteristics, essentially, or efficiency characteristics. So we really try to break it down into its most basic form and then work from there. And so we formalize that into what we call AO core, this notion of hash paths, some collection of inputs expressible in a single address. So you can give an address to a computable value without having computed it yet. And then also add attestations on top of that. So you want to be able to say, for example, if that computation that was happening was scheduling a message, well, then you would want some kind of attestation on top from someone that, hey, this is the thing that I did. And that has to be introspectable and verifiable. Or say it's a compute output. You want to be able to compare the outputs of two computations from two different nodes. Well, you have to have the ability for them to attest to the output. So those things turns out actually the same. And we just went further and further down this path until we came up with the most basic expression of what a blockchain is, I think, and formalized it into a small protocol. It's not as simple to use as like AOS in some sense from a user's perspective, but that's also like Arweave, right? Like no one ever uses the API of Arweave to upload data directly themselves as an end user. They always use it through some kind of application on top. And so we broke it down into this minimum, sort of minimal, elegant, reusable structure, if you will. And then from there, started building back on top of it things that are closer to AO processes as we understand them today. And the reason that I totally get it. It's like the system became more complex or confusing from a user's perspective as we got to mainnet. But the reason that we thought that this was worth doing, and I'm still certain that it is and was, is that now we have really robust foundations to build upon. And so when we add to the system over time, say it's this type of compute today, or I was just working with Claude a few days ago, or Codex actually, to see if Codex could implement Arweave as a scheduler. Turns out it's pretty good. So using Arweave as a scheduler, that's a different type of scheduling system. Shouldn't have to build an entirely new node type called an Arweave SU. No, that's just a little tiny module inside AO core, which runs inside HyperBeam. And now we have all of these composable, reusable units that you can remix to build whatever it is that you want to do, even down to like serverless functions where you pay in X or Y form, all sorts of things that were completely out of scope for AO, the processes version. It's much, much wider. It's more like a decentralized physical infrastructure network operating system. And then, yes, you can do AO processes on top. It's kind of like you see the top of the iceberg, and we exposed just that little bit before. And now we've built out this huge structure underneath that puts us in really good footing for the future when we want to expand on it, or when teams in the ecosystem are doing things with it that we never imagined they would originally. And that's already happening, like APIS and Load Network. Even people building like ZK virtual machine implementations, all of this stuff that just would never have been possible with the more primitive architecture that we had with LegacyNet. Now we can support it in this kind of more robust form. But yeah, certainly like getting there was not it was quite the road.
Yeah, I think it really like explained that way. It makes more sense just because when Hyperbeam came out and I started like looking deep into it, it sort of became like, as you explained it, like there is this part of the iceberg that's not seen, which is Hyperbeam, that can do a lot. But then now AO on top of that feels like just one use case for what Hyperbeam could do. Like
Exactly.
another possible use case, you just talked about serverless functions and all those type of things. and I think there is more that we'll see coming out from Forward and like other people building in the ecosystem to just make use of Hyperbeam, and also especially that it includes HTTP as well. So like it's just using protocols that exist already and just adding like another layer on top, and that can, I think it will bring out so many use cases that we don't even know yet.
Yeah, for sure. I I'm really interested to see what will happen when we have the first truly Hyperbeam native HTTP 402 payment required. What you say? Yeah, implementation stack or substack using the TEEs to TEEs locally scheduled processes, these things called hyperledgers. You can glue all this stuff together so that you can just send payments with HTTP requests, like natively in one packet. No waiting for consensus, no importing some JavaScript library or something. It's just all, using the native language of the web. And that's just one cool thing you could do with it. That just waiting for someone to pick it up and put it into
Yeah, I'm
production.
excited to see those use cases coming up. I think we'll just do like one last question since we're literally running out of time, real quick. Yeah, so as I think the way I frame it, and I think probably that's how it was, like from February when we had the mainnet event, uh, to me, it felt more like the road to mainnet sort of saying, where we had like these, we had steps where I think there was payment, then there was compatibility with legacy net. And recently, I can't remember if it was from the AO Twitter or the Forward, but I saw where Hyperbeam I think it's called Milestone 3 was complete in complete. And so, yeah, can you just maybe talk about that? What does that mean, and where does the rest go from here in terms of usability and all that? I've also started seeing Bazaar is fully on Hyperbeam and all that. So, can you just talk about that real quick?
Yeah, absolutely. So where we got to in February was, I would say, AO core protocol stability. So if you, there's this module called HB AO. It's the Hyperbeam implementation of the AO basic protocol, and it hasn't changed really since February at all. That's the basic, I should say, substructure of the system. That look, you can create hash paths that link computation outputs with attestation of cryptographic identity. So some person can attest that some computation at some address is some value. This part of the system, yeah, it's been stable since then. But I completely agree, and it was super confusing, and we could have done the communication there so much better. That hindsight and hindsight and time will yeah tell you these things. But in reality, you're just working with what you have, and everyone was working incredibly hard to just get the basic part of the system out in a fashion that we knew we wouldn't have to go back and correct later in a large scale way. But yeah, so that gave us AO core, but well, that's not AO processes, right? And so there was a stack of devices that also launched at that time, probably have to go back and check, but probably about 15-ish, that let you do things like relay to other HTTP services. And so the basic idea with Milestone 1 was, okay, let's take AO core, the thing that is the like fundamental driver of the network, and let's use the payment systems that Hyperbeam provides, which are devices that run inside AO core, that you can put on the front of a more traditional legacy net system, so that people could pay to get access. But bluntly, this was just too complex to communicate to people and help them get on board with. And eventually we just thought, okay, well, let's just jump to real AO processes running on top of AO core. And I mean, people did use Milestone 1, a few people, but it wasn't widely deployed. And we had a real communications challenge, I think, explaining like, well, there's many different parts of the system. What does it mean for you to be running on Hyperbeam certainly the like that basic version, and even today with Milestone 3, you're calling out in some form to a an implementation of the old virtual machine substructure, but now it's just kind of bundled into HyperBeam itself as a device, whereas previously you were like calling out to something that was external on a remote server. So there are all of these complexities, but broadly the structure we've been pursuing is, hey, get the core of the system stable first, which is what we did and shipped in February, and then make it so that people can start processes, just pure Hyperbeam processes, to begin with, and then go, and that's master two, and then go from there to legacy net compatibility. So running all of the old computation, smoothly moving it into the new system. And that was the big change about a month ago now, maybe 6 weeks ago, where something around the order of 90% of the computation takes place on Hyperbeam nodes in the background, running those, we call it Genesis WASM, the legacy net virtual machine inside a device inside Hyperbeam, so that now you can get cross compatibility between all the new stuff that Hyperbeam does, like all those balance exports, state reads, in the new AO core way, but also evaluate it just like they were on legacy net. And so smoothly moving the old system into the new system is essentially the idea. Well, I suppose smoothly, I think, was the intention. I wouldn't say it's been smooth, but it has happened. So it's got us over that line. From here, it's all about helping people build new Hyperbeam devices, making the processes easier to use on Hyperbeam. So I'm not sure if you've seen, but the experimentation with Hyper AOS, just like a Lua execution device in Hyperbeam that replaces the legacy net WASM virtual machine for people that don't need all of the things that WASM offers, and a whole bunch of stuff like this, just making it faster, more efficient, and getting back to making the onboarding smooth and nice for people to use. I mean, it was a wild ride. We went from the testnet system was truly a prototype. It was pretty widely labeled testnet. People just started to use it, which was great. But then trying to bring that into the new system without changing making compromises on the protocol that would hurt long term. It's been a real journey to sort of make that jigsaw make sense. But I think now almost all of the old compute is turned off. It's all running inside Hyperbeam. Next is pushing messages, scheduling, just on the Hyperbeam side, turning off the legacy net ones, so moving over the schedules from legacy net. There's a bunch of stuff still to do, but to give people a scale of the engineering that's going on. I think Hyperbeam is now something like 65,000 lines of code-ish, and Arweave is 40. And it took us 8.5 years to build Arweave. And lines of code is not like a great measure for functionality, but it gives you some rough metric of just quite how much this thing does. Anyway, so it's been quite the journey, but grateful for people bearing with us. And excited now that we have the right fundamentals in place and also all of the key computation moved over.
Yeah, nice. And I've also just been very excited about like the way things are working, because at least at this point now we can see, like, again, as I mentioned, Bazaar I think has completely moved to Hyperbeam, and you can feel I don't know if this is because of Hyperbeam, but I can feel the speed now on how things load and all that. And I think also just seeing most people in like the Discord running their own node with Hyperbeam, testing that, it's been exciting, and excited to see more of the apps in the ecosystem shifting towards that. Just because in testnet, and it was testnet and understandable, there were some things not working at some point with like some apps in the ecosystem.
Yeah. It was free compute is the killer, it turns out, but that's discussion I'm afraid we don't have time for today. Free is actually not the problem, I think. It's just unmetered is the killer. But anyway, I digress.
Um, yeah, nice. Yeah, and I think just a last word on that. And also, like, I think I don't know who mentioned this, but like that also just pushed people to start doing not unnecessary things, but like things that would take out a lot of compute on testnet.
Yeah. Was it like 1,200 dry runs in order to load Permaswap, or Bottega was like 400, and to open Arconnect was something like 50 to 100 dry runs just to serve one user. Yeah, it was interesting. Metering of compute is a good idea.
Yeah, I agree with that. So yeah, Sam, again, thank you very much for taking the time to do this. It's really been a pleasure to me to have you as my first guest on the podcast. I'm really happy about that.
Of course, yeah. Thank you, and wishing you many interesting conversations to come.
Thank you very much, Sam.